Hi everyone and welcome to the last fun session of Introduction to Cryptography. Today we'll learn about the great Enigma code and how the machine worked to create such fantastic and brilliant codes. We will make our own DIY Enigma code to learn the mechanics. But before making the unbreakable codes, let's get to know the Enigma more. So an Enigma machine is a famous encryption machine used by the Germans during World War II to send coded messages. It allows for billions and billions of ways to encode a message, making it incredibly difficult for other nations to crack German codes during the war. For a time, the code seemed unbreakable until Alan Turing and other researchers exploited the weakness in the implementation of the Enigma code and gained access to the German codes, allowing them to design a machine called a Bombay machine, also known as the Enigma code breaker, which helped them crack the most challenging versions of Enigma. Let's see how the Enigma machine works. Enigma machine has a keyboard, a lamp board, rotors, a plug board, and internal electronic circuitry. The machine uses a substitution cipher, but a very brilliant one. Each time a letter is mapped to another letter, the entire coding scheme changes. Because whenever a letter is pressed on the keyboard as input, the rotors move, changing that same button route to float current into a different path, revealing a different letter on the lamp board as output. This means that a message AA can be encoded at something like TU, even though the same key was pressed twice. Every month, Enigma operators received a code book which would tell them the settings used for every day, and every morning the code would change. This greatly increases the number of possible encoding configurations. So let's make our own DIY Enigma machine and try to make the unbreakable secret codes. Enigma machine had a keyboard to press the input letters and the lamp board to give the output letters. When a key on the keyboard is pressed, one or more rotors move to form a new rotor configuration which will encode one letter as another. Current flows through the machine and lights up one display lamp on the lamp board showing the output letter. So if B key is pressed and the Enigma machine encodes it as E, then E would light up on the lamp board. In our Enigma 2.0, we have the input/output ring. It takes the input keyboard, we follow the current route and come back to the input/output ring, which gives us the output, lamp board. Enigma machine had different rotors, each rotor providing a different encoding scheme. In order to encode a message, the Enigma machine took 3 rotors at a time, one in each of its 3 slots. Different combination of these rotors produced a different encoding scheme. If arrangement is 3, 2, 1, it means rotor 3 is in the first slot of the Enigma machine, rotor 2 in the second, and rotor 1 in the third slot. The slots are numbered from left to right. In our Enigma 2.0, we have 3 different rotors. Just like the Enigma machine, you can also play with their arrangement. On each rotor, there are 26 alphabets along the rim. So the operator can set it in a particular orientation. For example, the operator would turn the rotor in one slot so that J is displayed, rotate the second slot so that S is displayed, and rotate the third slot so that R is displayed, hence making the key as JSR to start with the Enigma coding. The message recipient can decode the message by setting their identical Enigma machine to the same settings that were sent by the sender's Enigma machine. In our Enigma 2.0, we have 3 different rotors, and just like the real Enigma, we have 26 letters on the rim so that you can set your key and do the encoding and decoding. Turn the rotors so that the 3 letters of your key are in line with the shaded bars. Let's say our key is JSR. On a real Enigma machine, the positions of the letters and the turnover points on each rotor could be changed by pressing a pin and rotating the outer ring relative to the position of the wiring inside the rotor. This was the part of the machine settings that change on the daily basis, hence making the messages harder to decode. In our Enigma 2.0, we have 3 different rings so that you can place over the rotors. Make sure the rings can still move over the top of the rotor, but also it stays in the same place relative to the rotor when the rotor is turned. Plug board had 26 sockets representing each letter, which can be connected together in pairs with jumble cables. If a letter has no connection to it, it passes through unchanged. Any 2 letters connected together will swap with each other before being passed through the machine and then swap back again for the output. Before any further scrambling happens from the rotor, this adds to the first layer of scrambling where the letters connected together are encoded as each other. For example, the plug board settings is K/T, G/W. So K becomes T and G becomes W. If I press the key T on keyboard, since K and T are paired on the plug board, T is now encoded as K on the static wheel, and the current passes through rotors and reflector and comes out as W on static wheel, which again changes to G because G and W were paired. So now G lights up on the lamp board. In our Enigma 2.0, we write the changed letters in the boxes on the input-output ring. For each letter that is paired, write the paired letter next to it. For example, if K and T are paired, write T next to K and K next to T. Do this for all the pairs, and then for the rest of the letters which have no connections, let them be as it is. Use a pencil so you can erase it to use again. For enciphering and deciphering, start tracing the line from the new set of letters, go through the rotors and reflector, and let's say you come out at W, but W is actually G, so you read off the new set of letters where you finish tracing the line. Make sure that the shaded bar on the reflector and the input-output ring line up. This indicates the start position of our Enigma machine and helps us track the turnover positions of the rotor. Rotors turn every time a letter is pressed on the keyboard, which changes the entire coding scheme. The actual Enigma machine had very clever rules on how these rotors would change. To make it simple, here is how we use in our Enigma 2.0. Every time a letter is pressed, turn just the right hand rotor one step towards you and make sure that the other rotors and the input-output ring stays still. When the right hand rotor does one full rotation, that is, after 26 letters have been pressed, the middle rotor steps down one time, and when middle rotor does one full rotation, the left hand rotor steps down one time. For each letter in your message, find the letter from your message on the input-output ring at the right hand side and trace the line from it through all the three rotors into the reflector and out again, back through all the three rotors into the input-output cylinder again. Write down the letter at which you end up. Let's say we need to encode message Enigma with plugboard settings A/G and I/T, rotor settings 1, 2, 3, ring settings 10, 12, 21. So the ring settings denote the position of letters, that is 10 becomes J, 12 becomes L, 21 becomes U. E is GOT. And after encoding, our message becomes LOVFXC. Give this encoded message and the machine to your friend, and others won't be able to find that the message you sent was Enigma. Now let's try decoding. Our encoded message is QFH and plugboard settings B/E with rotor settings 1, 2, 3, key dog. I wonder what that could be. So when decoded, QFH became BYE, buy. This Enigma 2.0 is a very clever and easy way of understanding how the real German Enigma machine worked. If you like this activity, do give this video a big thumbs up, share it with your friends. So lots of love. Let me know your comments in the comment section, and I hope that this course has helped you learn a lot of new and fun activities to send secret messages. Unfortunately, our journey has come to an end, but don't worry, because I'll be seeing you guys in another hobby as another course, and together we will learn and grow. So before I leave, I just wanted to ask one thing. What's your hobby?